So it's 12:05. Hello, everybody. We will get started for today. Thanks for being here very much. I'm Casey Londergan. I'm a professor at Haverford College. I use he and him pronouns, and I am the lead PI for LABSIP, which has had one online event before in November, and this is our second online event. We're really happy that you can be here. So let me tell you, for those of you who have not been here before, let me tell you about who we are. Oops, let me go back here. So these are the current LABSIP funded PIs. We have a small grant from Research Corporation to get this started, but our hope is that this will become a much longer lived community project. And in general, we are interested in finding ways to help instructors improve the student experience in physical chemistry classes. And we are looking forward to working with all of you and with lots of other colleagues of ours in this sort of broader community of physical chemistry instructors. So here is where we have been and where we are, right? This is still relatively early in this project. Our general goal is to uncover and support changes that move towards a more creative, inclusive, and energized physical chemistry curriculum and student experience. That's what we want in a general sense. And what we are doing today is, with your help, to clearly define the space and resources that could best support that development. We are very early. We might like to head in the direction of something like Viper that the inorganic chemistry community has, but we may have other priorities in our community. And so those are the things that we would like to be able to identify today. We're going to be here for 3 hours. The first hour is to basically work together, mostly in breakout rooms, to identify the priorities that we have as a community. Hour 2 will be centered around hearing from an expert, right? So this is Joanne Stewart, who's one of the founding members of Ionic and Viper, and she will tell us about her experience with Ionic and Viper and give us some reflections based on other communities of practice that have started in the last 15 years or so. And then in the third hour, then we will start to plan together, brainstorm, but also come up with more sort of practical ideas about how we can move forward as a community. So beyond today, our hope is to start to involve many of you in potential sort of parallel projects along these lines. Thank you very much for being here. Thank you in advance for your ideas and your energy and your enthusiasm. One thing that we have seen between November and today is that this is a community that's really hungry for a space in which we can share, in which we can work together. And so we're just really excited to be able to share that with you. So then beyond today's workshop, we do have an in-person workshop set up to think more specifically about learning goals for physical chemistry and to think more about the sort of curricular piece for physical chemistry. We will report back to all of you on that. And then beyond those 2 workshops, we will be looking at an expanded web presence that hopefully today will help to define a little bit more, and then we will be involving more people as time goes on, probably starting at the end of this summer and the beginning of this fall. So again, thanks for being here and thanks for your willingness to pitch in and get involved and give us your feedback at this point, but also your willingness going ahead to potentially be involved in some of these projects that we will identify starting today. Okay, so we will be working together in groups of multiple sizes today. We will be talking all together in the main room, but we will also be doing a fair amount of work in breakout rooms. And so our guidelines for today are just to please be respectful of others in the virtual space. We will be doing lots of brainstorming, and so don't immediately pass too much harsh judgment on ideas that you hear from other people. Please pursue productive disagreement and take notes, even on ideas that there may be some disagreement about in your breakout rooms. Please do be self-aware and refrain from any language that marginalizes anyone based on race, gender, ethnicity, or any other identifiers. Please be respectful and kind and gracious to each other. Since we will be working a lot in breakout rooms, we are recording the main meeting, but we are not recording the breakout rooms, right? Zoom makes it kind of hard to record breakout rooms, especially if we continue to pop in and out of them. And so please do write things down in the spaces that we provide. This is mostly going to be Google Docs today. Please take notes on what's happening in the breakout room, because that is our archive of what happened and of all the ideas that we have had together. Again, the breakout rooms are not recorded, so please take good notes when you're in the breakout rooms, and that will mostly be notes in the Google Docs. And we'll talk a little bit more about that in a minute. Okay, I am going to stop here and pass it over to my colleague, Brenda Rubenstein from Brown University. And Brenda is going to tell us about sort of what we know up to this point from our November event.
Hi, everyone. Can you all see my screen? We good? Excellent. I wanted to extend the welcome to all of you from all of the LABSIP coordinators today. And what I wanted to talk about to bring everybody up to speed are some of our November meeting findings. So for those of you who weren't able to attend our November event, which is completely fine, and are joining for the first time, we just wanted to acquaint you with what is it that we actually discussed. And as I go through the different results that we have from those discussions in November, I want you to think about, how do you resonate with those different results? Or do you think that there are other things that would improve the PChem curriculum or other resources that you would be interested in? We'll be branching off of those topics during the course of this discussion today. So for those of you who weren't here, we had a kickoff event November 17th, 2022, and this was fully on Zoom, but it was incredibly energetic. So I hate to share with students that we're getting energized about teaching PChem, which seems like being nerdy about nerdy things, but in fact everybody was super enthusiastic about that. We had over 150 participants from a very wide range of institutions, ranging from R01s to community colleges, all share their thoughts and much of their research about teaching physical chemistry. And so two of the things that we did during that time, so number one, during the first hour, we had breakouts on shared community challenges. So we asked the questions, what are the challenges that you face with student learning? What resources would be most useful to overcome some of those challenges? And what specific content would be most important for your PChem classes? I'm saying this because I'll show you what people thought in a second. During the second hour, we had a whole series of lightning round talks. I see many of you gave lightning round talks on today, and so that was fantastic. I'm just showing a few of these to show a lot of the novelty and innovation that's going on in this area. So we had some discussions about specifications grading, POGL for physical chemistry, Bloom's taxonomy for biophysical chemistry exams, and several talks about computing in chemistry. So a lot of people are thinking about how do you incorporate things like machine learning? How do you incorporate things like just numerical calculators into our physical chemistry curriculum? And so if you're curious, you can certainly go to this website that we have here. All of these talks are recorded. You can certainly sample from some of the best pedagogical approaches. So during that first hour, what did we actually find? So we asked a question about community challenges, and you might see one of the number one community challenges about physical chemistry was physical chemistry. But aside from that, what you can see is that many individuals express issues with things like retention, involvement of students. You can see that math is a big one here. And so some of the key themes that came out of this discussion, number one, textbooks. And we'll talk more about this in a second. A lot of the textbooks are somewhat encyclopedic in many people's minds, and they're incredibly what we've coined gas phasey. So I'm an electronic structure theorist, I guess, by training. I enjoy the gas phase, but many people think, maybe we should be thinking about beyond the gas phase and how do we educate students beyond the gas phase. People also thought that they were inaccessible and sometimes inflexible, particularly to modern students' needs. Huge topic was math. Everybody discussed math. The fact that many students come ill-equipped for the math that we're going to show them in physical chemistry, or maybe they are equipped, but how do we incorporate all the math that we have to teach into physical chemistry? Sometimes it's its own course, or you can take half of your course to try to teach all of this math. But math was a huge challenge. A couple of other things. Number one, there's cultural intimidation. Many institutions, students are afraid of teaching physical chemistry, but see it as a necessary evil. So they're there. So how do we destigmatize? And the content is challenging. And I think this will be the bread and butter of a lot of our discussions today is that we're always balancing depth versus breadth. So for example, we were talking about the gas phasey nature of many textbooks, but then also how do you teach quantum mechanics if maybe you don't reference the gas phase? So there are questions about, if you want to expand beyond, say, standard traditional material, how do you do that without completely overwhelming students? We also discussed resources desired. Again, math stands out. But many people were interested in things regarding repositories. Could we actually set up a repository to store all of our different materials and to help others quickly pick up physical chemistry teaching? So an enduring topic during our conversations was, many people had to or start their classes from scratch, had nothing, no other preparation, really not even notes. And so how do you quickly get started on PChem in a way that resonates with students? People were lacking the resources to do that. There were also a lot of discussions about what do you actually do with lecture. So if we had alternative resources, so somewhere in here is YouTube, if we had resources like, let's say, YouTube channels, could we do fewer derivations during lectures and more and engage more with actual physical chemistry topics. And so just to round out these resources desired, new textbooks responding to what we were discussing before. So things that are skinny, maybe less gas phasey, math resources to better support students of all different levels, maybe less focus on by hand calculus. So thinking about how do we incorporate computation or numerics into our courses, more on data science. Many people felt that would be extremely valuable, and the need for better pedagogical resources and the sharing of those resources. So lastly, before I hand it off, one other thing that we did during our November meeting is we used all our ideas. Hopefully many of you are familiar with all our ideas. I'll show you an example in a second, but basically you can compare two ideas and you can rank one as higher than the other. If you do that over a series of ideas, this website comes up with a ranking for all of the perhaps many hundreds of ideas that people thought about. So we have Julio on our team, and so we felt like we had to torture him. Just kidding, but we took his textbook, we took his table of contents, and then we asked people to up and down vote different topics from that table of contents. So here's an example question where people can say, what would they think is most important between these two different topics? And so going through that, we worked through all of those ideas for thermo and all of those ideas for quantum mechanics. And so here, starting with thermo, as you might expect, many people agree that the most important things are sort of the most fundamental things. So really getting at the first and second laws, entropy, enthalpy, Gibbs free energy. If you like TOEFL plots, I guess sometimes I like TOEFL plots. Unfortunately, you're out. Those rank towards the bottom. So some of the more specific content areas rank towards the bottom. We can ask, why that is, or how do we incorporate those? That should definitely be a theme of discussion. In quantum mechanics, again, we find that many of the more basic things, the fundamental things like solving the Schrodinger equation, were up at the top, but many of the applications were ranked towards the bottom overall. And so this suggests, there is a key body of literature that we expect people to understand, a key body of material that people should understand. But at the same time, how do we integrate that with more specialized topics that many of us actually think are important to research overall? So with that said, hopefully you can think about these findings. We're happy to share these different slides and share the different websites. I had put the websites where you can find some of these results with you, and you can sort through them. But the key question is, do you agree? Do you disagree with these findings? And which resources would you most benefit from? Are they really the same things that we mentioned before, like repositories and new textbooks, or are they completely different things? And so it's our hope today that you'll have a chance to discuss these different things and help us further narrow down and refine our plans for the future. And so with that, thank you all for listening. Happy to answer any questions, particularly on the chat, because we're limited on time, but I'll hand it off and hand it back to Casey.
Thanks, Brenda. I'm just finding my next slide here. Okay, so hopefully you all can see my screen share now. So we will be sending you to breakout rooms in just a minute. If you have any questions for the group or questions for us, you can feel free to drop them in the chat at any point. But we are going to be headed to groups in just a minute. And so to set up the breakout rooms, when you go to breakout rooms, we would like each breakout room to have a clear note taker. And so this is the first alphabetical last name in the room. You all can figure that out. And then we also need a timekeeper in the room, and we will give you a specific set of questions with specific timing for each of those questions. And this is actually sitting in a Google Doc. So here, I'm going to chat now the link to the drive space that we're going to use for this meeting. So if you go into that drive space right there, it's basically just a folder that has a whole bunch of different Google Docs for breakout rooms. Please don't open the Google Docs yet. You can open the Google Docs once you have been sent to a breakout room. but I want to make sure that you have that link in the chat before you actually send, before we actually send you there. Okay, so we have 2 group roles. You're going to be in breakout rooms of about 5 people. So these are going to be smaller rooms where you can all talk to each other, and facilitators will be coming around. We will be coming and going from your groups, but please do your own work together. And you can always hail us in the main room if you need us. These are the discussion questions that we would like you to pursue. And so I will also put these in the chat right now. They are also sitting in the Google documents for you. So here are all the questions in one big mash in the chat, right? Here's a list of them, and they are also listed out. These basically just reflect what Brenda said, right? Do you concur or agree or not with the findings that we already have from our November work together? And then, you know, questions 3 and 4 basically are, what are the resources that would make the biggest difference to you? So with that, I think, yeah, so I've sent you the Drive link. So the Drive link is in the chat. Make sure that you all can get to the Drive folder at least. And then when we send you to the breakout room, you're just going to open the Drive folder for your breakout room once you see what number breakout room you're in. All right, so let's head to breakout rooms. We will be there for about a half hour going over all of these questions, and then we'll come back before the end of this hour to just break down a little bit sort of what we've seen, but please do take good notes in your Google Docs. All right, so we can, yeah, open the breakout rooms, yeah. And everybody can, you should be invited to breakout rooms in a minute and can head to those breakout rooms. Okay, it's 1:05 Eastern, so it is my great pleasure to introduce Dr. Joanne Stewart from Hope College. So Joanne, after a PhD at Berkeley and a postdoc at University of Minnesota and a number of other exciting things that she has done, she has been a professor at Hope for quite some time now. I would say that the second half of her career has been distinguished by the fact that she is a real sort of leader, and I would say guru at this point, in the sort of communities of practice. And this is because she was one of the original founding members of Viper over here, right, which many of you who may have overlap with inorganic chemistry may be aware of. And many of you actually have mentioned in the Google Docs and stuff already. So, so Joanne is here to tell us about her experience with getting a community of practice going and about what she has observed in consulting with other communities of practice. And we are just really lucky and grateful to have her here today. So Joanne, thank you very much for being here. Joanne is going to talk for about 15 or 20 minutes, and then we will have substantial time for questions. So please write down and think of questions. If questions bubble up for you while she's talking, you can drop them in the chat, and then we will have moderated questions and answers for a while after Joanne has finished with her screen share. So I'm going to stop my screen share and let Joanne start her screen share.
Great. It's really a pleasure to be here. I'm really excited about all these folks. Also, if I would say, Casey, if there are questions in the chat while I'm talking, feel free to interrupt at any time. Sometimes it's nice to do it kind of in the moment. Casey and I met in San Diego. I was on a sabbatical. Actually, I'm just coming off another sabbatical. So it must have been 14 years ago, 21 years ago. I don't know, probably, who knows? I had a kindergartner and a second grader at the time. That's what I do remember. So it was a great sabbatical at UC San Diego, and a real pleasure to get to know Casey at that. Just a few disclaimers to start with. So I will talk about this inorganic group called Ionic. We've been around for about 14 years. And so a lot of stuff has happened in 14 years. And so I'll try to explain sort of some of the things in terms of where we got started, but do understand that some of the stuff I'll be talking about didn't happen overnight, happened over a long period of time. Also, that this is just one story, and there's actually a lot of communities out there in chemistry right now, and they're all completely different and doing different things, which is awesome. And also that, we started with maybe a couple $1,000 perhaps from Mellon that allowed some of us to get face-to-face in a meeting to sort of figure out, not unlike this, but it was kind of pre-Zoom. And that was really all we had when we got started. And it was quite a while after that we were able to get some funding to do what we wanted to do. So as Casey said, I do have a short presentation here. Oops. It's having time. All right, so can you see my slides okay? All right, so so there you can see our logo, which we didn't have for the first few years, and you already have a logo, so you're way ahead of us. And then the little chiclets in the bottom of Ionic, we like very, very bad acronyms using symbols from the periodic table because we're inorganic chemists. And then this sort of come for the content, stay for the community is just something that we've used for a long time because we really did start out focusing on how we could share inorganic chemistry content, teaching content, but it was really all about the community. So Ionic is the name of the group. Viper is the name of the website. We don't care which you use and we don't care what we're called. It's one of those names anyway, but that's sort of where the names came from. So what I want to do right now is sort of three things, and that is this sort of one thing we always really struggled on was the elevator pitch, because we knew we were a group, we supported each other, we mentored each other, we shared stuff, and whenever you would try to give an elevator pitch, it was a fail. And so I would, kind of challenge you all to figure out what it is exactly you want to accomplish, and can you say that in a concise way. I would say we're still only moderately good at that. And then the question of how you're going to communicate with each other and how you're going to share information. So I'll show you our website that we developed, especially to share chemistry content. And then, is it working? Evidence for effectiveness. Also, then I've got just a short section on lessons learned, if you will. So we finally settled upon the fact that our goal is simple. We want to improve teaching and learning in inorganic chemistry. But this was not all. We've spent a lot of time talking about our research programs with one another, supporting each other in research as well. So it's not solely about teaching and learning. But I would say that that's our primary push. And then also all of inorganic chemists and most physical chemists teach Gen Chem as well. So a lot of what we do overlaps with Gen Chem. And so we hope that we've played a role in Gen Chem as well. So what's the problem? What is it about inorganic chemistry that we sort of feel we need to improve or fix? And so I'll just share what are some of those challenges. One is just the stupid breadth of the topic. So bonding and orbitals, coordination chemistry, bioinorganic chemistry, main group chemistry, F element chemistry, and materials and more. And so, and at many of our places, this all needs to be covered in one semester. And so, so that was a real challenge. So also as a side note, inorganic chemists love different representations. So we love all these symbols. The other problem for many of us, even though our membership spans a broad range of institutional types at this point in time, initially it was quite a few folks at smaller colleges. And so we'd get an exciting idea, I want to go talk to somebody, and we'd look out in the hallway and this is what we would see. And so a lot of the reason that we pulled together initially is because we were lonely and we needed somebody to talk to about teaching inorganic chemistry. Trying to stay current in all of those subdisciplines I listed is impossible. I can barely stay current in my own research area, let alone all those other areas as well. And so this sort of avalanche of information, we can help one another with managing that avalanche of information of what's going on in research in the different subdisciplines. And then in addition to that, staying current on teaching and learning ideas and technology and diversity and inclusive teaching, and go on and on and on and on. It's a lot. And so we help each other with that. So those were some of the challenges, the reasons why we want to come together to work on inorganic chemistry. So when we got started, we initially said, well, it was at a time when the National Science Foundation was starting these digital libraries in the different sciences for the physicists and the biologists, et cetera. So we said, well, we just want a digital library of resources. And we were working with an educational technologist at the time. And he was like, no, you don't want a digital library. Those are dead in the water. You want to make a community. And we were like, no, we really want to make a digital library. And he's like, no, you want to make a community. And so we said, what's a community? And he tried to explain, bless his heart, but I don't think we got it. I think it probably took us 2 years at least to figure out what Ethan meant by community. But we were able to start sharing materials. And so we developed this Viper website. So we did get then a big $10,000 grant from Knightley at that point in time, and that launched the website. And initially it was just the teaching resources. Over time, it has evolved to be a lot more than that. So you can see there's four major sort of links on the front here: teaching resources, workshops, community, and the Fellows Project. Initially, it was just teaching resources. We have a little sort of announcements blog called Bites. You can see the snake theme running throughout things. On the right-hand side, we have sort of what's new on the site so that when people go on it, they can see new things. So yeah, so we did set up a website and get things rolling. And we did work with external folks to help us in setting up the website. We sort of designed it and then they made it look good. That's what we spent our $10,000 on. And so the web address for that is ionicviper.org. And it's open. Almost everything's open on the site. There are some answer keys that are behind a firewall. And you are all invited, welcome, encouraged to sign on to sort of register on the site. So almost everything's open without registering. But there are some answer keys, some things that are blocked. So register, ask for faculty privileges, and come join the party. All right, so what did we share? We decided we wanted bite-sized, manageable, adaptable pieces of curricula to share, which we call learning objects. And so they are just a problem set question, a laboratory, a literature discussion, etc. And these are the little bite-sized pieces that we have on our site that we've shared. So if I go to teaching resources, the way that inorganic, and if you look at the site, it should just scream inorganic chemistry at you. That's the idea here, is that shamelessly, these images are things inorganic chemists love and resonate with. And so we have all these cool little icons and stuff of the different areas. So that's one way that we sort the site. Another way that we sort the site is by the type of content we have. So if I were to click on content up here, I get this drop-down menu that shows the type of learning objects that we have. So we did not want your lecture notes, but sometimes somebody had something interesting to say. So we did add sort of something called 5 slides about, which is just like a short little 4 or 5 slides, PowerPoint slides on cyclic voltammetry or some special topic, but we don't want your lecture notes. In-class activities, lab experiments, lit discussions, etc. So, and then a few other things that have been added over time. We wanted some low-hanging fruit, things that are easy to put up there. So this web resource and apps, if somebody has a cool website or resource like that they found, they can share that on the site. And so also sometimes these sort of problem set questions, if you just have a cool question that you did not steal out of a textbook, but you made up yourself, you can put it on there. And then what we decided early on was that we wanted to sort of we are all big believers in the peer review process. We all are journal publishers. We all are, peer reviewers, et cetera. We deeply believe in the peer review system. But for this type of a sharing, we wanted to really open it up to be more flexible than that. And so our idea is that we use this sort of publish then filter mode instead of filter then publish. So things that are put up on the site, they are reviewed by a team of reviewers. There is feedback given to the authors. There are corrections made, et cetera, but I would call it sort of review light. It's a gentle reviewing. And then they're put up on the site, and if they're good, they will get used and downloaded and sort of rise to the top kind of thing. And things that are not good will just sort of disappear off the bottom. And so that's why we call this publish it, get it on the site, and the community will naturally filter what you've put on there. And each learning object that's on the site also has a commenting. So that's the community social site of the section, has a commenting section on it. So they can, once it's up on the site, people can say, hey, I found this mistake in your answer key, or wow, I really wish you would have done this instead. And all of these are living documents. So the author of this, unlike a journal publication, which is dead and done, these are all living so that the authors can make changes at any time and updates and whatever they want to do. Okay. So that I didn't show you a lot of the website because you can go explore it on your own. We have templates for developing these. We have workshops where we help people develop learning objects. Our big turning point was when we first started the website, we populated it, the leadership group populated it with their own materials. And when we crossed over from having, more things on the site contributed by external folks than by leadership, we knew we had turned the corner in the right direction. So that was exciting. We do a number of different things to make sure things are going okay. So you can see over the last however many years, we've had steady growth in both sort of registered faculty users. We don't have good web statistics because the site's open. So we can use Google Analytics. Well, we used to be able to use Google Analytics, but that doesn't really tell you who are bots and who are not and everything. And so we don't have great website statistics, but we do have statistics of who registers, even though we know there's a lot more people than that, probably 10 times that many people use the site. So we can track how many people have actually registered as users on the site, and then how many of these learning objects have been added to the site. And we've been shocked and amazed that it has grown in a linear fashion over time. My experience in sort of educational reform is that a higher ed project typically has a natural 5 to 7 year lifespan. Is how long projects usually last. There's nobody out there who will keep funding a project after 5 to 7 years. So the fact that this has gone on longer than that is very shocking to me and makes me very happy. All right, so that's a really quick introduction. And so now I just want to share a few sort of lessons that we've learned along the way. These may or may not match your experience or your goals at all. And so the first one is sort of, you need a league of your own. And so we've learned that to form a community does require some sort of commonality. And so you've got subdisciplinary commonality, which is the same that we have, but other folks are doing all different kinds of things as well. And so it really just depends on where you are in that regard. But we always talk about being shamelessly inorganic. And that's our identity. And we hope to influence Gen Chem, but we know where we come from. It's all just Charlie Brown adult voice to me. This had to do with working with Ethan initially. I vividly remember sitting down with Ethan a dozen years ago when he explained Twitter to us. And our response was, why would we want to tell somebody we're at the airport? Because the best we could tell, that's what it's like, hi, I'm at the airport, was what Twitter was for. And we didn't make sense of that at all, but Ethan was very, very patient with us. He also said, he was very good at sort of saying when we should just do stuff ourselves, of which we did most of the stuff ourselves, versus when we should call in some professional help. So he helped us find some designers. As chemists, we kind of need help with designers. So we actually hired a logo designer, and we hired a person to really get the look and feel of the site the way that we wanted it to be. Not tonight, I've got a headache, baby tenure, file lecture, whatever. And so this had to do with sort of getting the size of the leadership group right. And sort of 7 to 8 was the magic number for us, because out of that 7 to 8, 2 are always out of commission. So I skipped over so that's Hillary Epley with our first Viper baby. So he was born in kind of the year after we launched the website, and he's going into ninth grade now, which is pretty amazing. But yeah, so the leadership group needs to be of a size that people take charge and get things done. But when somebody's having a time when they can't contribute, it doesn't mean they're off the team. It just means they maybe go quiet for a year, and you need to be able to allow for that. All right, copyrights, commenting, and crowdsourcing. Oh my, you need to figure out how you're going to share materials. So we use a Creative Commons license on our materials. So basically anything that goes on the web is yours. You own it. You don't need to do anything more than that. You put it on the web, you own it. But what you can do is lease it for other people's use. So Creative Commons is a way that's worked out well for us. We tend to, just lease either completely open, do whatever the heck you want with this, or some people like to put a non-commercial, do whatever you want with this, but don't sell it, kind of a license on there. We leave it up to the contributors on our site. We also had some lengthy conversations a dozen years ago with Journal of Chemical Education. And at that point in time, they, and I don't, this could have changed since then, but at that point in time, they recognized that what we were doing with this sort of living, changing, always changing site was very different from a polished paper in JChem Ed. And so they have never been very strict with us about, we're able to pop stuff up on Viper site and then publish about it later, still without the worry of, oh, you've already said this kind of thing. But you would all have to sort of sort that out on your own as well. All right. The thing that has been one of the crucial things for us has been our integration into the inorganic chemistry community at large. And the ways we've done that is we have had almost consistently somebody from Ionic on the leadership group for the Division of Inorganic Chemistry. And so it's just been good to be in that room. So you you've got such a huge response of interest. You probably have somebody in the room there. And so DIC has been 100% behind us all along. On a number of occasions, we've written into our grant proposals that they would back us up if we ran out of money for something, and we really haven't had to take advantage of that. They've given us a little bit of support over the last 5 years for our website, which has been really generous. We wrote that into a proposal. So being, part of DIC has been really important to our work. We do a big symposium at the spring ACS meeting every year, which really focuses on research done with undergraduates. The talks are primarily faculty with one or two really exceptional students. And then the poster session is done within the inorganic chemistry poster session. And we have 100 posters that's mostly students in that part of it. And we've been doing it since 2008. And it's just been, it has been an open door for some faculty, a lot of faculty to do their first national meeting. And so it's an incredibly supportive symposium. It's just a great place to have a safe home in a big national meeting. The other thing we did is we broke into our journal, which was quite a trip. We were so excited. So we planned a strategic sort of attack of all the editors and things and said, we want to be in Inorganic Chemistry, the ACS journal. And so this was our first paper, which was about the community, written for the inorganic community at large, not for the teachers and not for the, whatever, but really for the research community. And then we've been back in there another time since then as well. So we've got a really good working relationship with all the, we all review for them, right? And so we've got a good working relationship with inorganic chemistry, with the journal. All right, and then if it's not obvious, you got to have fun along the way as well. And so with the snake themes that we run with all the time, that was our first logo. Don't ask me where that came from, but we ran with that for a while. And that evolved over time into something that started to look a little better, and no cigarette, no beret this time. And so that was our logo. So when we went to our logo designer, we went with something like that. And our poor logo designer kept giving us all these swirly snakes, and we're like, no, we want a coiled snake. And then kept sending us snakes, and we said, no, the snake has to look friendly. It can't look scary. And we must have gone back and forth 30 times with what the eye and what the tongue looked like at the snake. And so we finally, I don't know what you think, it looked kind of friendly to me. And so that was how we finally ended up with our logo. We have so many snakes that come to all of our meetings with us. This was sort of the original leadership team a long time ago. And for those of you that know any of these folks, so much change. Oh my gosh, so much change since then. We've sort of tried to write, currently, a number of the original leaders are sort of slowly exiting and have been mentoring new leaders. So at the last project meeting, we had at least half a dozen or so new leaders involved in the group, which has just warmed my heart and made me very, very happy to see that. And there's another snake in the background again as well. So that was in January, I think. And you'll notice I am not in that picture on purpose. So I guess I'd like to know sort of how can Ionic help your group, and what kinds of things would you like to know, and encourage any of you anytime to just drop me an email with questions that you might have about how we communicate, how we sort of got through this this landscape of growing a community. So thank you.
So please join me in thanking Joanne. And the floor is open for questions. We have plenty of time for questions. So please drop your questions in the chat, ask them live, whatever you would like to do. I'm sure this is a great opportunity to pick Joanne's brain while we've got her here. And then we will talk together amongst ourselves in about, starting in another 15 minutes or so.
Can I ask first? I know you just spent an hour brainstorming and discussing and stuff. So could I ask first for 2 or 3 of the sort of things you see your community pursuing or doing? Can a couple different people maybe share what came out of their conversation?
That sounds great. Yeah. So would any of the recorders perhaps like to share your top 1 from your list?
I don't mind going from breakout room 2. One of the things we talked about is that several of the people in our group were aware of existing groups of people who teach physical chemistry, who have been working on pedagogy and have great ideas about how to teach lecture or lab and that sort of things. But somehow it seems that the dissemination and the community and the organization part of it is lacking, because there's also a lot of people who don't know about these groups. And so we talked a lot about how perhaps LABSIP, since it seems to be getting a large number of people, a lot of interest, could help in connecting the existing groups and spreading the word and being able to form that community that you talked about so much.
Yeah, hi, we're from group 1, along with the networking group, building the repository, which, Joanne, you said was the first thing you wanted to do, but really the networking was the second thing you wanted to do. That was our experience in POGIL PCL. We wanted to build a repository. We wanted to get people together in that order. And it turned out that getting people together was more important than building the repository. But I think that having a functional repository is something that, we're all struggling with, because it's how do you put these things together in some form that everybody else can get access to them. And I know that our group has been struggling with it, along with some others, just to sort of make it in a way that you can all get access to it, but also sort of recognize that people still have some ownership over the things that they have put up there. And that's sometimes a tricky area. I know that the Ionic people, you've sort of worked this out, but not everybody is of the same mind in other groups.
Thanks, Alex. Other recorders?
Yes, this is from group 11. One of the things that we thought about in terms of the structure is to have subgroups, maybe as a way to bring it down, where you'd have groups organized around a particular set of topics, like, for example, computational, introduction of computational work in PChem, or even maybe dividing that into smaller groups. And this group would meet more regularly than, once every couple of months. And it would be kind of a working group, at least to start. So that's what we thought would be important.
All right, so I see other hands up, but let me interrupt and say a couple things here. Those are all awesome. I think that, there are a number of groups out there. Casey and a few others there are aware that I'm working right now on a NSF proposal to try to pull together. So what we want to do, and it has to do with sort of a theory of change in higher education. And what that is we want to build bridges between these groups, so they do know more about what one another are doing, can learn from each other, and basically increase our effectiveness at bringing about change, improving teaching and learning in higher education. So you know, your group and POGO PCL and others have agreed to come play with us. We may or may not get funded. We never get funded our first time out the door. Every Ionic grant proposal we ever wrote took 2 or 3 tries before we ever got funded. And it was painful and we did it and whatever. But so building these bridges between the groups. So if you were to sort of do that with the physical chemists first, that would be really, really awesome. Because that would just make our work even that much easier in the long run. And so our goal is, again, to sort of build what are called wide bridges between the different groups. And we have a list of probably a dozen or 15 groups in chemistry. A lot of them are computational folks. Some of them are subdisciplinary, some are lab related, various things. So I'm excited about that, and that you're aware that there's a bunch of groups out there that are doing similar kinds of things, and that's great. We started out, so then about subgroups or teams or whatever. So we just started out with this leadership group of 7 to 8, and that was our first few years, was just there. And so we just sort of populated our repository with stuff we do. You know, it's something I do in my class already. And that's where we kind of got started. And then what we did was we started doing summer faculty development workshops. And we kind of did them on the cheap. We did them at specific campuses. People stayed and they had roommates and all this kind of stuff. We did have a little bit of NSF money to do that. And at each of these summer workshops, I won't go into all the details of how it works. Some of you have been to them. We developed content for the site at the summer workshops. And that was, boy, you left the summer workshop a published author on the site, which was a very cool thing. And so this sort of a concrete product out of any of the work. So having a team that has a product come out is a great idea. That's a great way to do it. We haven't done sort of like, we tried a couple different things with lab development that we haven't been particularly successful on. So so go POGO PCL and everything, you know, but what we have been successful on is we have these things on our site called lit discussions, which the goal of a literature discussion is actually not necessarily to teach the literature. The goal of a lit discussion is to teach the essential content in inorganic chemistry. So crystal field theory, molecular orbital theory, et cetera, to teach that essential content, but to teach it in the context of a cutting edge paper. And so a literature discussion on our website is a student handout with really specific questions getting at that content area. Look at figure 3, look at the crystal field splitting diagram, et cetera. So not saying you can understand all this research. We don't expect that. There's a beginning student, you know, but using the literature to understand fundamental chemistry content. And so what we've done, what we've had a good success with, is when some occasion arises, and the last few years, the occasion has been the awards that the ACS gives out, we will develop individually, collectively, whatever, a lit discussion for each, related to each of the award winners' area of research. And I just finished one for Polly Arnold. We have a LGBTQ collection that is Pride Month. And so I just finished one on Polly's work on, and also I was a uranium chemist, and long story. And so that was a lot of fun to write that one. And so we'll have these like themes, and we can create these collections on the site related to awards or related to some event that's happening. And so I wouldn't really call those teams. They've been kind of loose knit groups of people saying, we're going to put this together. But what we do have is, after we realized that the 7 or 8 leadership folks that we had could no longer manage all the different activities that were going on, we do have we have probably half a dozen teams. We have Team Bug, which is our website people. We have Team Outreach, which goes and tries to get new members. We have Team Workshop, we have Team Research, you know, so we got a bunch of teams anyway that do those various things. And then the last thing is about the repository. We spent a long time sort of storyboarding and whatever you call that, and all those things, the site. And particularly, we spent a long time figuring out what a learning object consisted of. And we also spent a huge amount of time on metadata, and don't even get me started on that. Fortunately, JChemEd had lists of metadata that they were willing to share with us. And that's just sort of like, what's the topic area? What's the level? That's all the metadata that goes when you set up a learning object. And then, you know, I told the group when I joined, I was like, if you ever want to get a penny from NSF, you have to have some sort of assessment information with it as well. And the whole group was like, no, we're not going to do that. And so what we ended up doing, and this won't surprise any of you at all, and that was that we kind of sat down, they understood that this was important. They did get that. At that 12 years ago, we couldn't use the word assessment because people would run screaming out of the room, and that may be similar now, I don't know. And so we use the word evaluation, which is not rigorously the correct term to use, but we did it on purpose. So there's in each of the learning objects, it has, how would you evaluate whether the students learned the stuff or not? And what was your experience with evaluating that sort of? And so you'll see a lot of our learning objects, somebody has just developed and put it up and they haven't even really taught it yet. It has like very almost little to no evaluation information on it. And some of it really shares, you know, students got 7 out of 10 when I quizzed them on the following or whatever. And it does have that information. So yeah, so each of our learning object types, whether it's a lab, experiment, or problem set, has a slightly different template associated with it. So our platform sits on top of Drupal, which is an open source program, but we did hire the coding of the templates for the learning objects and all that kind of good stuff. We can do almost everything ourselves on the site, but there's a few things that we still farm out to people with more expertise. All right, I'm not anything in the chat.
There's been a little bit in the chat. Joanne, I have a question for you a little bit more about sort of, you mentioned that you had a digital technologist that you were working with at the beginning. What was the background of that person and where would you recommend that we, you know?
So at the time he was at Reed. And so there's a Reed person here, right? I know there's a Reed person here somewhere. Oh no, it's Lewis and Clark person here. So he was at Reed. His undergrad work, did he have a grad degree? His undergrad work was in biology, so he talked science, thank goodness. So he kind of got us because he had that science background. But he was an educational technologist hired at Reed to be their ed tech guy. And he was big in EDUCAUSE, and 15 years ago, EDUCAUSE was huge into communities of practice. So that's where that, so I never understood where this whole community thing came from, but it came because Ethan had just been doing all this EDUCAUSE work and they were big on communities of practice. So, so that's where a lot of that came from. So a lot of you, like Hope, where I work, we don't have one. And so some of you may not have one. We don't even have, well, we don't even have a teaching learning center and I don't want to go there. But a lot of you have sort of ed tech design folks or something like that in your teaching learning centers. They're awesome. They're brilliant. And then he found for us the designers when we hired, and we didn't have very much. We had a logo design and we had the look of the website design, but we storyboarded the whole, we had already really set it all up. They just made it look pretty.
Gotcha, thank you. Other questions for Joanne? We have a little more time.
Well, so I'll ask one. Hi, I'm Kana. So I'm wondering, like, when you mentioned you were designing this, you know, you were like data first and then community second, and you were like, oh no, I wish we had, like, so if you were starting over with thinking about, okay, how do I make this community focus and data second? How would you have, do you think you would have, how would you have changed your strategy? Online versus in person now? I'm very.
No, I don't think we would have done anything differently, because what happened is when we designed, and this has changed a little bit over time. So when we designed the website, it was specifically designed for community. So it wasn't a dead website. So we had forums, because this was before Skype and before all, so we had forums and we used our forums. Okay, our forums have now been replaced by a Discord site. But we had beautiful forums for communication on there. Every single learning object has commenting on it afterwards. We tried to do a 5D orbital rating system to try to rate the LOs, but it turns out if you want to do a rating system, you need about 1 million+ participants for a rating system to work. So don't go there because nobody will use it. So the 5D orbitals are gone, but we thought it was fun at the time. So the website was built for that sort of flowy community back and forth. And so one thing I did not include in my talk is I have a lovely example of, like, somebody posted a learning object with a really cute little applet in it. And somebody else said, wow, that's really great. I wish it did X. And so the author was like, oh, I can make it do X. And they posted that. And then, well, that's really good, but it really should do Y. And they did that. And it was awesome at that point in time. And then even after they finished that, there was still a lot of commentary afterwards. And everybody sort of says how they use it and how they've changed it. Sometimes it'll be a learning object that somebody, like people really like, and they change it so much that they repost a whole new learning object of how they do it at their institution, kind of thing, because it's different enough. And again, we don't sweat that, you know, and so that there's not a lot of that, but there's a couple of examples. There's several examples of what do you do on the first day of class, and they all are have some relationship to one another. So we designed the website with that community. The 7 to 8 leadership folks had so Ethan, our ed tech guy, said, if you don't stop sending email messages now, I will kill you all. And so he set up a little Skype chat room for us. So that Skype chat room has been open and running for 14 years now. And so we have our communication. During the about a year before the pandemic, the Skype chat room with the 7 to 8 leaders, we all these teams, and it just wasn't working anymore. So we set up a Discord site. So there's which has 8 million channels, and you're all welcome to join our Discord site. Just go to the website and it'll tell you how to do it. And so there's a channel for the leadership group on there. And the Skype thing that we've had for 14 years, that is now just friends, right? That's not Ionic anymore. So it still exists after 14 years, but the Discord site has become our hub. And so the forums, I think the forums might still be on the website, but really they've been replaced with the Discord site. And there were reasons why they chose Discord over Slack that I don't know, but whatever, it doesn't really matter. But having that home for these continual conversations has been really important.
There's a lot there. That's really, really helpful. Jonathan, did you have a question or a comment? You had your hand up for a little while. I just wanted to make sure that you got to say what you had to say. Okay.
So the other things that I think we've done well, I said the 5D orbitals didn't work. There's a number of things. The forums really ended up not working that great. We really want people to post comments after they use a learning object and say if they liked it or didn't and what they thought of it. It's pulling teeth to get people to do that, but we do. So whenever we have a workshop, we're like, all right, everybody, pull up an LO and comment on it right now. That's how we get commenting on the LOs. But everything we do, all the workshops that we do and all that kind of stuff is all everything and the teams and whatever, everybody has a project. Everybody they got to make something. We never get together just to get together. None of us have time to do that. Alex was talking about sort of, the credit and stuff. I have to be honest, we've done 3 NSF grant proposals. You get to put 4 PIs on the grant proposal. We have always put as the PI, and then everybody else is senior personnel. We've put out of whoever's involved in doing this, the 4 PIs have been the people who are either coming up for tenure or coming up for promotion. Everybody works together on it, but they are the ones that really need this. So, I was never on a grant until this last one of any of those things, because I already had tenure. So and promotion. So it didn't really matter to me. It was about getting those people's names on there for because we don't get credit for it. I don't want to be too cynical here. We get relatively little credit for any of this. That's a fact. And so therefore, we really have to work hard to get what little credit we can out of it. Another thing we've done that started in the pandemic is we have a series, now we're up to number 50 of webinars called Slithers, snakes. They're all on YouTube. And I did a webinar about how to put this type of work into your tenure and promotion package. So if any of you have questions about how to do that, Ionic has a YouTube channel. You can go to our YouTube channel or you can search it on the Viper site as well. You can find it lots of different ways. You go to our YouTube channel and I have and you can listen to it at double speed. So it goes pretty fast. And I have a slither on how to put this type of work to get the proper type of put it into your, your CV and put it into your tenure file and all that kind of stuff. I have strong feelings about a lot of that.
Awesome. Yeah, and I think that we are, strongly represented in new faculty in this group and sort of attendees today. So that is super, super helpful. Yeah, thank you, Joanne. Please, everybody, join me in thanking Joanne again for her time. Joanne, you are welcome to hang out while we sort of now see what we've aggregated from our first hour.
Yeah, I'd like to hang for a little while, so thanks for that.
So I think Kelling has a screen share now that will report back sort of our aggregated top 5 that we will then proceed to maybe talk about here in a few minutes. So Kelling, when you're ready.
Yeah, sorry for that. That's a rookie mistake there. So we met and looked at all of the outcomes, and this we're sharing with you some that rose to the top 5 general categories of priorities that rose to the top. The first one is under the broad umbrella of community engagement, and some proposals that came in that regard are Slack channels. So setting up Slack channels through which people can discuss particular aspects that are of interest to them, but primarily to bring the community together as well, just so that people have connections, because some of us are in departments where we might be the only person in physical chemistry or just one of 2 people in physical chemistry. And so we don't get to see people a lot who have common interests academically or pedagogically in the subdiscipline that we work in. And also having regular workshops or Zoom sessions, not unlike the one that we had in November or a forum like this. Also possibly having also newsletters where we can share on particular things that are new developments in areas that we are interested in, and focused virtual communities. Those could be maybe people in a particular area, if you are in the same state or you're in the same part of the country, or if you have a particular interest on a particular aspect of physical chemistry education. And also to having a virtual directory of our peers. So somebody who is really interested in developing materials for thermochemistry might have their name and email address somewhere in that particular interest, and somebody else who needs some material in that area might be able to check the directory and see a name and an area of interest and just write to that person directly. So community engagement is one priority area. I should emphasize too that when we say priority here, as priority 1, it doesn't mean that was necessarily the predominant topic. It's just in one of a list. The next priority is repositories and open resources. You probably heard this in your sessions because we saw it a lot in many of the different breakout room notes that we looked at. And some of the ideas are approaches to using AI or ChatGPT, for example, in the classroom or in teaching physical chemistry. Also teaching materials that have to do with active learning or grading, for example, specifications grading or other approaches to grading materials. Numerical and computational resources, which could be R or could be Python, could be so they could Excel, MATLAB, and so on. And shared lecture notes, so shared lecture materials. If you are very interested, for example, in an area that's not especially commonly taught in physical chemistry, let's say EPR, for example, but you have a lecture that you gave on EPR that you think undergraduates would be interested in seeing, then you could include it or provide it for the community to be able to share with their students. So that's the idea there. Also having shared sample problems that might help faculty with problems that they could use in active learning experiences in the classroom, or maybe exam questions, and so on. The third area that we noticed was having more virtual peer-to-peer community learning, peer-to-peer learning community. So this is related to community engagement, but in a way it's a bit more targeted, where people are coming together to focus on a particular thing. The initial community engagement idea was just to bring people together, But here, the idea would be similar to what we have sometimes at our universities, where we have faculty learning communities. This would be peer-to-peer learning communities for physical chemists interested in a particular, very well-defined topic. So also under this general category comes new faculty. Several people felt that it would be nice to have some way of helping new faculty to think about some things that will become crucial for them, especially in the first year. And so this might be a place where new faculty could be brought together, probably with a few experienced faculty members, to have a session to think about the experience of teaching physical chemistry. Supporting training in new areas for experienced faculty. Maybe people have been teaching for 10 years, 20 years, but have never used Python in their classroom before, and they're interested in doing so. This might be a place where we could help to bring people together. Also forming new support or accountability groups. This leans in the direction of mentoring communities. So possibly having a range of people from different areas. New faculty, maybe some senior faculty, people who are mid-career, and having a forum where they can come together, maybe in small groups, to try to provide some accountability and also some support, sharing things like ranging from sharing materials for writing grants, probably, which is of interest to many of us, or just teaching a particular thing in a way that's engaging in the classroom. And the fourth priority item was laboratory development and enhancement support, providing resources for developing and implementing innovative and effective laboratory activities is one area of interest. Cures came up too in the discussion. So course-based undergraduate research experiences, and also providing connections in interdisciplinary ways. So physical chemistry connected to data science, or physical chemistry connected to climate change, or linking physical chemistry in other ways that might be of interest to students. Some of us teach biochemists physical chemistry. Some people might be teaching people from other areas too, like environmental studies and so on. And so having a place where labs could be developed that are innovative and creative and make these connections would be useful. And also we include here calibrating expectations. This has to do with calibrating student expectations so that they don't come into the lab too anxious or have great apprehensions limit the learning experience in the classroom. And the fifth priority that we found from the materials are generally have to do with textbooks and syllabi. And so having access to textbooks, whether this is through free materials online or providing access in some other ways. Also sharing how we structure our syllabi to help students in the way that we write them, or different approaches that we take in the classroom and how we describe that in our syllabi, which may be especially helpful for new faculty as well. And also promoting textbook modernization. How do we inform the textbooks of the future to help us to be effective in the classroom? And also very generally open education resources, which links as well to improving access. And so those are the priorities that we have. And I think I leave it here and mention to you that as we discuss these topics, you might find new priorities. So one of the questions that I think Casey will take up now is whether there are new priority items that we should consider based on what I just outlined or what you heard before from the Viper presentation. So Casey, it's over to you.
Thanks, Kelling, and thank you for the quick turnaround to those of you who just did all this aggregating what's in all those Google Docs. I have chatted a single question right now that you can all see. Here is a rechat of the Drive link. We're going to send you back just for, we're a little bit later than we want to be at this point, but I'm going to send you back to breakout rooms for 5 minutes to answer this question in your group. So these are going to be the same groups that you had before. This is a single question, 5 minutes, quick hit. Are there new priority items beyond these 5 that were just presented there? And I will blast these to your rooms once you're in the rooms, right? I'll blast you what the list is. So the 5 again are community engagement, repositories and open resources, virtual peer-to-peer learning, communities, lab development and enhancement support, and syllabus structure, textbooks and learning outcomes, right? Are there other things that you would like to upvote, right, that aren't on that list based on what we heard from Joanne and what we heard from this hour's discussion? So you have about 4 or 5 minutes back to breakout rooms. Please take quick notes in your Google Doc in your breakout rooms, and I'll see you in 5 minutes. Okay, everybody, that was super fast and it probably wasn't enough time, but I'm interested to hear, was there anything beyond our list of 5 that bubbled up for you as a priority that we should be adding to that list of 5 things? And you can all just sort of scream it out or put it in the chat at this point, right? This is a free for all for the next 4 minutes, right? To just see, what came up, right, for you, based on our having heard from Joanne, having heard about Ionic Viper, and then comparing to our own list of 5 things that we came up with.
Well, group 11, I think we had discussed how to start. Do we start with individual groups and that then merge together, or are we waiting for some super organization? I think we thought that maybe starting on small groups, like around a particular topic, like new labs or sharing labs, and then that could be a starting point for a group.
So yeah, so divide and conquer in small groups.
Yes, yeah, or tiptoe in the water rather than just plunge in.
Yes. Other new ideas or priorities beyond our list of 5 things. We will certainly during when I bring you guys out, we're going to take a break in a couple of minutes. When I bring you guys back from the break, we are going to start talking practically. And so some of this divide and conquer is something that we can start to talk about at that point.
In room 3, something that jumped out was the importance of prioritizing community over repository. Hearing that experience in Viper, I think, stood out to us as something to take to heart and emulate. So sort of playing on Michael's idea there, if you have a Discord that can then have channels that target those specific smaller group goals, that's one way to kind of like materialize that vision.
Yeah, one way to begin to organize things. Yeah, thanks, Tim. Yeah, and my sense is that this is a group that is, sounds a lot like the inorganic chemists of 15 years ago that Joanne was talking about, where a lot of us feel like we're on islands and we want friends and we want to be hanging out. That is certainly a message that I have heard from this group since we started this project last year. Other sort of priority things that are, bubbling up as a result of hearing from Joanne and hearing about Ionic and Viper and communities of practice. Okay, if not, I think we've all got a little bit of steam coming out of our ears at this point. So let's take a 5-minute break. My slide is going to say we're going to start at 10 past the hour, but we're going to start at 14 past the hour. So let's take a break. I will see you all in 5 minutes. Okay, everybody, we're back. Welcome back. And so we are going to relatively quickly send you back to breakout rooms for a longer discussion at this point. This is going to be about 25 minutes of discussion. We're going to cut it a little bit shorter than it says on the sheet so that we can come back and hear from each other and have a sort of a real report out at the end of this. So what we have done for these 5 priority areas is to assign breakout rooms to talk about these specific areas. So you will find your specific priority topic of these 5 that Kelling introduced to you in your Google Doc when you get back to the breakout room. And also when you get to your breakout room, I think your breakout room will also be named for the topic as well. So hopefully it's relatively clear what you're supposed to be talking about. And we would like you to answer 2 questions. The first one is, how could we best advance this priority for our community? This is basically brainstorm. Tell us what you think all the things are that we could do in this area. And then I think this sort of more practical thing, which we also want you to cover towards the end of your discussion, is what are short-term steps? What is the low-hanging fruit, right, that we could be, thinking about plucking off in this area? So we are going to actually, we're going to use the same breakout rooms, right? We're not going to reassign people. So you may be talking about something that is not necessarily something that is a huge priority for you, but we want this to be a community discussion. I think this is sort of the best way to do it, at least to start with. So let's do this for about 25 minutes. I'm going to quickly, again, re-chat the link to all the Google Docs. So let me just do that here. Right, so this is the Drive directory again that has all the Google Docs, and we will send you to your breakout rooms. There's just 2 questions. Please take notes on those questions. Okay, welcome back, everybody. So here is the list of priority areas that we came up with. So we assigned specific groups to talk about specific areas. I would guess there's going to be a little bit of cross-pollination here, but I'm particularly interested to hear from groups who were discussing each of these things. I don't know if any of you figured this out, right? But my students and I assigned you to, so we actually assigned 3 groups to topic number 1 and 3 groups to topic number 3 because of the emphasis on community. And then we assigned 2 groups to 2 and 4 and 5. So let's hear first as a report out from the 3 groups that we're talking about community engagement. Interested to hear the sort of general ideas that you had, and then whether there were sort of specific short-term priority sort of pushes that you would identify for us. So any of those 3 groups, please go ahead. We have about 4 or 5 minutes for you all to talk about what you came up with. Go ahead, Adam.
So I'll speak on behalf of Group 1 here. A couple of things jumped out, but I think we spent a fair amount of time discussing the idea of Discord or Slack servers, both as something even lower barrier to entry than a forum, but also something that could be up and running, in a matter of minutes to a couple hours of work. So really low hanging fruit. And once sort of a critical mass of people might be in there, the odds of someone being around to chat about a topic, or you share a new visualization and a couple folks around and go, hey, that's a cool idea. It's a good way to get people able to communicate about this stuff in a really informal, low barrier way.
Great. Other outcomes from, I guess, room 2 or room 11?
So I'll talk for room 2. I will admit we didn't get much to the low hanging fruit part. We were talking more of the first question. We talked about how to have community engagement, we have to have a community that engages, and how that is challenging sometimes, especially to sustain that. And so we were talking about that it's probably going to be important to make sure that whatever we're doing is valuable to the people involved, so that people want to stay engaged. And we talked about how that could be different things. And so it may be like Viper has a bunch of different subparts, and people probably engage more in one than the other. And then as their career develops, they may change from one. We talked about, in addition to repositories of teaching materials, we thought some discussion about how best to teach and implementation would be really valuable, at least to the people in our group as well.
Yeah, great. One thing that I can sort of, I guess, upvote in response to sort of what your group said, right, is that I think that we had actually a really nice sort of nucleation of community around the physical division, the symposium on innovative teaching in physical chemistry. at the spring ACS meeting. And it seems like that's going to be a semi-regular thing. I will very much thank the organizers of that, including Ashley Ringer McDonald, right, who's here and who put that, she mentioned that in the chat at the beginning of the meeting. We are going to keep doing that, it seems like, right? And there are actually, I think the physical division of the ACS is very interested in continuing to do something like that on a semi-regular basis. And so that provides potentially a place that we can all, or many of us, can run into each other on a semi-regular basis, hopefully going forward. Anything else from group 2 or 11?
That symposium came up in our group as well as something that would be low-hanging fruit for people to join into. Another relatively low-hanging fruit that we discussed was having some sort of virtual coffee hour or discussion group that might start up. It would require a few volunteers to organize it, but not too much past that. And that might be a relatively easy way to get some synchronous community building started. So
Yeah, that's a great idea. Okay, awesome. Let's move to, I guess, topic number 2, right, which was repositories and open resources, right? So that was group 3 and 4. What did you all come up with? What were your thoughts?
Maybe I can speak for group 3. The things we discussed is the lowest hanging fruit would be using existing infrastructure. Could be something as simple as a shared Google Drive where people can post either their resources or could post links to other resources. There's a lot of stuff out there already, including YouTube videos and so on. And in contrast to Viper, when Viper started, 15 years ago, a lot of that infrastructure was not there, right? So they had to make a website. They had to be able to share everything on their own website. But nowadays, depending on the type of content, there's always a specific platform that's best suited. For example, if it's computer code, people might want to share it on GitHub, where if it's a video, YouTube would be more appropriate. So we don't have to have a single repository, but we could just have a place to aggregate links to other resources.
Yeah, and there are already examples of communities that are doing this that are linked to people in this community. For example, the eSkip Python project, for example.
Right.
Which, yeah, thanks, Carlos. Group 4.
Okay, I'll quickly speak to that. I mean, we hit on a lot of the same things as group 2, but something else we thought of as low-hanging fruit is one of the hard things is you've got to figure out what to link out to, what to collate. So I think some kind of a survey of people for what they have used that is available and useful. And we should rapidly populate a website with links to these and other resources, maybe temporary, but right, there should literally, as fast as we can, there should be a page, I don't know, LABSIP or something like that.
Yep.
I do think that the other things we discussed, we do need to start coordinating with all these other resources and see if we can put together something more like Viper, because as they said, as has been said, right, there's GitHub for certain things and other things for other things. That may or may not work, but it makes the living document for things that can be sort of computery works fine in GitHub, but for most of these other things, they don't work as living documents. And that's one of the key things that Viper does. But I would say GitHub or GitLab would probably be a place to start, because at least they have a review mechanism. They have a way for folding stuff back into text-based documents or even documents with pictures in them and equations through the use of Markdown. But again, it's another language some people have to learn to use. I mean, if you know how to use it, it's not a big deal, but there's a barrier there.
Yeah, thanks, Jonathan. And thank you, group 4. Yeah. Okay, the third area was virtual peer-to-peer learning communities. So that was group 5, 6, and 12. What do you guys think? What were your thoughts that you'd like to share with the group?
I can start from group 5. So one of the things we talked about is identifying a small group of faculty to sort of take the lead on any one of these. So for example, annual workshops for new faculty, we probably need some people to be involved in engaging with that, and thinking about either regional or national ACS meetings to host those as an opportunity. In terms of supporting training in new areas for experienced faculty, we talked about either having tutorial videos that sort of walk faculty through it, but then also facilitating small groups where faculty could struggle, help each other learn how to work through an activity if they have that tutorial that they can sort of reference. And then in terms of the short-term steps, we need to choose a communication platform. That was like one of the first things we said, decide on what that's going to be. And then also have a survey to help pair people. So think about asking questions about, do you want to be paired with people who are in the same region of the country as you, at the same kind of institution you're at? Who teach thermo before quantum or quantum before thermo, and those kinds of questions. And then we also thought about the survey including like a way for faculty to rank how comfortable they feel with certain skills or content topics to help pair maybe faculty who feel like they have a weakness in one area with faculty who have a strength in that area, so that there can be some teaching back and forth. So those were some of the things we talked about.
Yeah, a lot of scaffolded networking in there. Yeah, that makes a lot of sense. Yeah, thank you, Heather. Other groups, 5, 6, 12.
Sure, we talked mostly about kind of synchronous workshops that could be offered on specific topics. And so this could be pretty low hanging fruit with sending out a Google form to gauge interest of people who'd be up for planning and implementing one of these workshops and leading one of them on a topic that they have expertise in, as well as gathering interest from people who would like to attend these workshops to make sure that the ones being offered match with those that would have reasonable interest in attendance, and making sure to reserve part of the time during those workshops for networking time or just collaborative exercises to get people talking, to make sure we are providing that sense of community.
Yeah, nice. Yeah, thank you, Sarah. And was that, Sarah, you were group 6, is that right?
Yes.
Is group 12 out there?
Yeah, we were actually assigned the peer-to-peer virtual section. And so within that, we discussed some virtual and some kind of the balance between virtual versus in-person meetings. And something we discussed for quite a bit was less low-hanging fruit and more a concern of keeping virtual meetings shorter. That webinars could be really useful if they were maybe a 20-minute conversation with 10 minutes of Q&A, and so you're able to fit that within a teaching day, and then having resources be recorded and uploaded pretty rapidly to maintain interest for the people who aren't able to attend the actual live session.
I think that those ideas that you both just presented, those definitely provide clear practices that we should try to follow, I think. So yeah, so thanks, Natalia. Okay, so topic 4 was lab development and enhancement. And so this is an area where I think that we don't want to reinvent the wheel too much, because there are some adjunct communities to us that are already sort of in the middle of this kind of thing, OGL, PCL, et cetera. But I'm particularly interested to hear what those groups had to say. So that's group 7 and group 8, I think. What did you think about labs and lab development and providing support for lab enhancement?
Yeah, in group 8, we discussed these topics. However, a lot of the things that we did discuss did come up, so I will not repeat many of the things that I just heard. One thing that did come up is like a lot of folks are, they have not done the lab experiments that they are doing for their students since their own undergraduate days, or forever altogether. And therefore, having things like videos on how to install equipment or how to get the lab going would be very useful. Another topic was that we sometimes, when we say physical chemistry lab, we are very much focused that it has to have like the label physical chemistry in it. And sometimes a lot of the things are not formally physical chemistry, but yet they can be addressed by physical chemistry tools and people can connect with them. Examples are NMR spectra that are pretty much in a whole lot of departments, and people can do like spin coupling and such. Or examples are like collaborating with astronomy friends to get spectra of the sun and things like that. So people should be on the lookout for those things also. Like we don't have to basically be very physical chemistry focused. Another thing that came up was basically piggybacking on ACS and MRS and other larger national scale conferences to promote this community and get together with people. One final thing is that I guess it doesn't fall under the labs in general, but it came up several times, and that is that as we are building this community, we should be tolerant of flaws and tolerant of mistakes. A lot of folks are probably very much hesitant to put out their teaching materials and then feeling that, oh, I will be judged by these people in the LABSIP community because they will find my flaw and think very less of me because of that. So I think the culture of helping each other without judgment should be in this group, and even those of us who are the senior people should post things, and we should be okay with people criticizing us and such. That may be a barrier towards people wanting to post, because they will wait until their materials are absolutely perfect, then they will post, and that will take too long. So therefore we should be tolerant of flaws and mistakes. That's what we discussed.
Yeah, thank you. And that's very consistent with the sort of Ionic Viper idea of publish and then edit, right, that Joanne was talking about. Yeah, thank you, John. Group 8 or 7.
So we, I guess, echo a lot of what's already been said, but one thing that we talked about was, as there are these groups out there that already exist, like Pogo PCL and Piper and whatever, is maybe trying to create like a smaller subgroup under the umbrella of LABSIP, where we can pull people from these existing groups to kind of create this subgroup where all of this knowledge can then be compiled, and that may come about through setting up a Discord server. We spent a bit of time discussing that, and then so that's kind of the low-hanging immediate steps that we envisioned being taken. And then beyond that, as we compile these resources, is not just compiling experiments, but thinking about instructor resources. So like, what's the lab equipment? What are things that the instructor would need to know outside of like what the student sees in their lab manual to sort of facilitate that lab use? Those are kind of two of the things that we discussed that haven't been touched upon yet. So
thank you very much, Safa. Okay, and the last topic, the fifth topic, was syllabi, textbooks, and learning outcomes. To some extent, we are going to be running an event next month that I think will be not completely, but I think focused in that direction. So, we could potentially get some marching orders from groups 9 and 10. So groups 9 and 10, what did you have to say about syllabi, textbooks, and thinking about learning outcomes?
Yeah, so one thing that we talked about was kind of trying to just understand what the community is already doing. So like what topics are being covered, what order are they being covered in, and whether we can make some kind of repository for syllabi, or even some way of kind of going through these syllabi and actually generating statistics about how PChem classes are being taught right now. Another thing that we talked about was prerequisites for these courses. So what are different universities requiring in terms of, what level of math, whether people are teaching thermo first or quantum, because that can make a big difference on kind of the content of these courses. Let's see what else. For textbooks, we wanted to also just kind of ask the community what textbooks they're using and why. And we thought that a big kind of barrier here also is how different notation is from textbook to textbook. So it's really challenging to kind of pluck out parts of different textbooks that we like and keep that consistent. And then learning outcomes, we mainly just discuss kind of what the ACS has already kind of put out and whether that's something we want to use as a community or whether we want to build upon that or change that. Yeah, I think that's about it.
Thanks, Connor. And the last group, last but not least group, what did you have to say about textbook?
Very, very last but not least, I feel like a lot of what we discussed was already discussed in other contexts. But I'll kind of highlight maybe some of the distinct things that we talked about. We talked about how it's hard to come up with a universal syllabus, and that maybe the upvoting that was already done was probably the most valuable thing that could have been done in terms of identifying the key topics. But there's also value in just, having a repository of different syllabi so you could just see how other people are teaching it differently and learn from that. And in addition to kind of thinking about what's included in a syllabus, having maybe some resource that lists different prerequisites, like mathematical foundations that are required for different topics. And also separately, maybe having some sort of, we weren't sure about the format, but maybe having like a wiki that also is organized by topic and then has just like links of external resources that people commonly use to support teaching and learning for those different topics. Like we were talking about how, I include a specific link when I'm talking about molecular orbital theory in my class. And so maybe that could be something that's shared in that forum. In terms of, let's see, I'm trying to remember what we talked about. For the short-term steps, one thing that again was already talked about was creating like very quickly either like a Discord, I don't even know what it's called, something Discord or a Slack channel for this group. But another thing that we thought might be valuable is connecting like subgroups of people, like 5 or 6 people together who have like shared specialties. Because one of the things that I found so valuable about like this workshop was just the informal conversations that were happening in the breakout rooms. And so having some sort of like sustained smaller community within this larger community to share ideas, I think would be valuable as well. Okay, that's it.
Yeah, thank you. And yeah, again, we're hearing community perhaps before sort of a super mature repository. Yeah. Yes. Okay, I will share my screen one more time here. So this is sort of where we got today. We are out of time, so I'm going to let you go in just a minute. And so I just wanted to thank you all for participating very, very much. If you have, I will hang around for about 5 minutes here. So if anybody is sort of interested in dropping particular links or ideas or things that are just bubbling to the top of your head at this point in the chat, please go ahead and do so. We will save the chat. We have all your Google Docs. You have created a whole lot for us to sift through, and we will be involving you. We don't have a post-meeting survey for you right now because we wanted to take at least a couple days to digest everything that sort of got put into these documents and stuff, but we will be back in touch with you, and we're very interested in trying to nucleate something like a Slack or a Discord server relatively soon, and in potentially also trying to deputize subgroups to work on specific things that we have identified as things that we may be able to get done relatively quickly. And we also have this event coming up next month in Tucson, where about 25 of us are going to be talking specifically about, especially about the things like learning outcomes and like, syllabi and things like that. Thank you very much to all of you. I especially want to thank all of the co-facilitators who I think are identified. You can find who they are by seeing who all the co-hosts are I would also like to thank a few of my students who were sort of lingering in the background, helping to run things and, you know, editing your Google Docs in real time and things like that. But mostly, thank you to you for being here. Thank you for all your ideas and all of your energy. I think this is a community that clearly wants more community and clearly wants to do more of this kind of thing. And so we look forward to, I look forward to seeing all of you again relatively soon. So thank you to all of you very much. Again, I'll hang around for 3 or 4 minutes if you want to drop things in the chat. And otherwise, I hope you enjoy your summers and conferences and whatever else is happening for you in the summer, and we will be in touch. Thank you.